Hello everyone and welcome back to Up 360 Circuits, your go-to channel for electronic tutorials, embedded systems and practical IoT projects. In today's video, we are comparing two batteries that may look similar on the outside but are built for completely different purposes. We have the GP Supercell 9V battery, a standard non-rechargeable battery, and the TWICELL 9V nickel battery metal hydride, a rechargeable battery. And we also have the TWICELL cell 9V battery charger. So yeah, we'll be looking at how each battery works, where it performs best, their advantages and limitations, and which one offers better value depending on your application. So let's get started. But first, we'll be looking at what a 9V battery is. So now a 9V battery is one of the most commonly used battery formats in electronics. And despite their similar sizes and shapes, not all 9V batteries are made using the same internal chemistry. So the type of battery depends on how much energy it can store or how much current it can deliver, whether it can be recharged, like the TWICELL 9V battery, or whether it cannot be recharged and how long it will last in different applications. That's why when we say two batteries are 9V on the labels, they can perform very differently in real world use. So the GP Supercell is a zinc carbon battery and is also designed to be a disposable battery. And what that means is that once the energy in the battery is depleted, it cannot be recharged. You throw it away and get another one. So inside the battery, there are 6 small zinc carbon cells connected in series to produce approximately 9 volts. So now zinc carbon batteries are popular because they are inexpensive and readily available, which means that you can buy them in almost any store, even at a random roadside store. Most of them have it. So yeah, they perform very well in devices with very low power consumption, where batteries are expected to last for months without drawing much current, like in a microphone, for example. Typical applications include TV remotes, wall clocks, smoke detector, and even toys with low power requirements. But for this kind of devices, the GP Supercell is a practical and affordable choice. However, zinc carbon batteries do have several limitations. They have relatively high internal resistance, which means that they struggle when powering devices that demand higher current, and that can lead to them draining very quickly. So if you connect one to, let's say, an Arduino project with sensors, wireless modules, displays, or servo motors, you would often notice that the battery voltage drops or drains very fast, much faster than expected sometimes. And since it cannot be recharged, every time the battery becomes depleted, you need to get another one. So for someone who builds electronic projects regularly, these replacement costs can add up quickly over time. So next, we would be examining the TWICELL NIMH 20 milliamp battery. So now, unlike the GP Supercell battery, the TWICELL battery uses a nickel metal hydride, which is also commonly known as the NIMH chemistry. It is also a 280 milliamp battery, and rather than throwing away the battery after one use, it can simply be connected to a compatible charger and reused again and again. So depending on the battery and how well it is maintained, it can typically withstand 100 of charging cycles before its capacity begins to decline. So you can charge it as many times as possible, provided that it does not drop below the charging range, which is about 1 0.5 volts. Although rechargeable batteries usually cost more initially, the higher purchase price is often recovered after like a relatively small amount of charge cycles. So imagine you initially purchase this battery and then after a project it drains and you have to get more. If you compare that to having this, compare it to the price that you used to initially get the TWICELL battery, since it can be recharged, the price is often like it is often cheaper to get the NIMH, is what I'm saying. So instead of buying dozens of disposable batteries every year, one rechargeable battery can continue powering the project for a long time. So another major advantage is its current delivery. So NIMH batteries generally have lower resistance than zinc carbon batteries, which means they generally supply a higher amount of current more effectively than the GP Supercell 9-volt batteries. And this makes them much better suited for applications such as Arduino projects, robotics, servo motor projects, wireless communication modules, portable electronics, and electronic prototypes. So these devices or projects often require bursts of current that disposable zinc carbon batteries struggle to provide consistently. Another thing to remember is that many rechargeable 9-volt batteries actually provide a nominal voltage of around 8.4 volts instead of exactly 9 volts. And this is completely normal and just due to their internal cell construction. And despite the fact that they have lower nominal voltage, they still perform very well in many electronic applications. So now let's put both batteries side by side. Let's just do a simple comparison. So the GP Supercell is inexpensive to purchase initially and it makes it suitable for occasional use and also very fast projects. But the TWICELL battery might be more expensive upfront, but is significantly more economical because you can charge it over time. It can be recharged a couple of times. um the GP battery is disposable. It means after the battery is depleted, you just trash it basically. And the twice cell can be recharged, is reusable. Once you recharge it, you can reuse it again. The GP battery is suited for light duty applications. So it cannot really, if you have a project where a high amount of current is needed, the GP battery might not perform effectively. But the twice cell battery is much better and much suitable for projects like that. And then so while both batteries certainly have their place, they are designed with very different goals in mind. So if your device only draws a small amount of power and you really need to replace the battery, obviously a disposable battery like the GP Supercell is still a perfectly reasonable option. But however, if you're someone who regularly works on electronics, robotics, Arduino projects, ESP32 projects, or even portable embedded systems, investing in a rechargeable NIMH battery is often more practical. Not only does it save money over time, it also provides better performance in many applications while reducing unnecessary battery waste. So for engineers, students, or even just hobbyists that are interested in embedded systems, it is usually an investment that pays for itself. Alright, so I'm going to be showing you how you can charge your NIMH battery. So I have a battery and a charger. So on both the battery and the charger, there are two connectors, the positive and the negative. And the battery also has a positive and negative connector. So what you do is you just switch the connectors, meaning that the negative on the battery goes into the positive on the charger, and then the positive to the negative. And just place it like this, and then apply just a bit of pressure and press it in. Then there's, yeah, you flip that and then just plug it into your extension. Yeah, as you can see, the red light indicates that it is now charging, and you can just leave it for a few hours, then come back and test with your multimeter to see if it has charged. Yeah. And so that is our comparison between the GP Supercell 9-volt battery and the TWICELL 9-volt NIMH rechargeable battery. Hopefully this video has helped you understand that although these batteries may look almost identical on the outside, their internal technology, performance, lifespan, and overall value are quite different. So if you found this video helpful, don't forget to like the video, subscribe to Up 360 Circuits, and turn on the notification bell so you never miss our latest electronic tutorials and embedded system projects. Thank you for watching, and I'll see you in the next project.